In this section, I want to highlight several important considerations to take into account as we create a regression table. As with everything in this class, given that it is social science and there's multiple potential ways of explaining an outcome, we want to start thinking theoretically in motivating the empirical research approach that we take. First of all, I would recommend, as we do with qualitative research essays that you might write in your upper level classes, you want to build on the best existing research that is out there that you've come across to help motivate the questions that you ask, the arguments that you're making, the empirical expectations, and the finding the best data that you can come across. And then the first kind of step to show that you're actually reducing the chance of error, because with quantitative methods it's so easy to make mistakes, to mislead yourself and to lead others, that you want to demonstrate and guard yourself against making as many mistakes as possible, and only then can you start to feel like you might be standing on solid ground and to be able to start making tentative conclusions. But all of it is preliminary and requires thinking theoretically and building on the existing research to kind of replicate the existing research, the approaches, and then add in your additional factors. So you control for the other explanatory factors that the literature finds important, and then you determine whether your own results support the alternate hypothesis on your main independent variable or variables, and then try to torture test your results to try every different conceivable ways of thinking about threats to causal inference, whether it's spuriousness, endogeneity, omitted variable bias, how sensitive your results are to the measures that you're actually using in your data. Do your data hold up if you're using different measures of happiness or different measures of GDP or other variables that um, could be measured in slightly different ways? And if you can approach it like in the example of democracy, if you have an estimated relationship between democracy and happiness, if you want to show that that relationship is robust and that it's not just a factor of whether you're choosing one measure of democracy, polity, over varieties of democracy, for example, you run the same model with both independent variables in their own separate models and then see if the results are consistent. And so what that does is it gradually builds confidence that your results are not sensitive to model specification, what variables you put in your models, what specific measures of those variables you put in your models, what other model variables you can include or drop from your estimation. And if the results all point in the same way, then you can really have a stronger case to be made that the relationship you're arguing for is actually present in your data. So how do we then turn practically? You want to make sure that you present enough results in your table and then in your interpretation in the text to allow readers to understand what you did, what regressions you ran, what data you were using, what went into those different models, and what their results are, and then allow the readers to reach their own conclusions about whether your results are both statistically significant and, I would argue, even more important, is substantively significant. And as students who have gone through this class often see, that you start when you approach a quantitative research article by basically reading some parts of the article, the words, the interpretation of the results, not directly the table itself. And then what we now are learning how to do is seeing how people decide to highlight certain aspects of their models and not others in their text. But then by looking at a table, you can reach your own conclusions about statistical significance and substantive significance. And lastly, I think it's underestimated how important it is to make sure you're transparent in your procedures to allow other people to run your same models. In the last page, I talked about how important it was to build on the best existing research to kind of show that your data and your approach can replicate or reach the same conclusions as to what other authors have done. Now you want to take your turn to be clear enough in describing what you did to be able to allow other people to replicate your research, to both um, allow them to add their own unique spin or additional variables or approach in their own research design, but also to potentially highlight the risk of mistakes because sadly, mistakes are quite common. There's a reproducibility crisis in psychology, and there's been a number of different high profile cases in economics, like here, but then also in political science, that it is often underestimated the importance of replication in building scientific knowledge. I mentioned in lecture the Reinhardt and Rogoff issue, in which you had some graduate students trying to replicate their data approach. They were also using Excel, and what the researchers found is that this high profile article, when they were highlighting a column, excluded several rows in their regression results. I think you've seen over the last couple of weeks how easy it is to make mistakes or to not highlight the correct cells or the ones that you want to highlight when you're running your results. And this is what full professors do as well. And once they included those excluded countries, including Australia, in their model, their results basically went away. Often, also, your results, you want to be able to establish what you did in a transparent manner because building on that might not seem immediately important or be recognized by the literature, but in the long term it will. This week in October, there's going to be the announcements of the Nobel Prizes in various subjects. Last year, the Nobel Prize for Medicine went to a professor from the University of Pennsylvania, Catalin Carrico. She was demoted back at the University of Pennsylvania back in 1995 because she was quote unquote not of faculty quality. Her paper that ended up kind of helping create a new subfield was desk rejected from one of the top journals back in 2005. However, she persisted. She kept on doing her analysis, publishing it in other outlets, even though the topic she was focusing on wasn't necessarily seen as fashionable or one that saw a bunch of opportunity to proceed with new breakthroughs. However, what we will see from her case, she was ended up proven right because her techniques and analysis of RNA enabled the fast development of COVID-19 vaccines using this mRNA technique and the analysis of RNA that she had established over the course of 15 years. So just because your results might be outside the norm, as long as you have the fundamental foundations of research design, theoretical explanations, observable hypotheses, and data analysis, in the end, it can work out. While the others, their conclusions can be taken as face value. However, on further analysis, they can fall apart due to research design. So that's why it's important to focus both theoretically as well as practically to making sure that we are on solid foundations and that we're not going to be found to have been making simple errors or complex errors in our research design, and that we can build on it and can end up having a much larger impact than some people might have seen a couple of decades earlier. So, in creating a research table, it is basically a summary of the entire research process in the empirical design section. You have to choose your dependent variable, which is often messy, it's time intensive. You might start with one variable, but then you realize upon analysis that it's not really the one that you really want to capture. There's multiple ways of defining a different variable, and even one factor like democracy that I mentioned earlier. Some people like varieties of democracy measure it on a continuous scale. They survey experts, at least 5 experts for each country. They get measures of how democratic a country is. They run a fancy Bayesian item response theory model to try to get a continuous measure of democracy for each year and every country. Others just have a dichotomous measure, like Jose Chaibub and others, just to say if you have an election and the winner takes power and the loser leaves power, that is one measure of electoral democracy. That is just a 0-1 kind of factor. Or your argument about democracy could should just be more the level of change of democracy. Is a country moving from an autocracy to an anocracy, democracy to an autocracy, or vice versa? What is the most important aspect of your factors, your dependent variable, but also independent variable, that you want to focus on? Lastly, you can, if you have a variable that has high profile outliers like Liechtenstein, the US, that have very high per capita GDPs, that could make certain observations influential, and that could distort your results. So by logging your variable, you make it more of a normal distribution to reduce the influence of outliers. And so there's all these inevitable trade-offs in choosing your variables and what you want to use. And in most research, most articles that have that make the effort at trying to have a solid foundation, they use multiple variations of their dependent variable and report all the results. Sometimes people who are looking to publish, the stakes are quite high for individuals in getting an article through the peer review process. They might just choose and justify the variables that they include as being the ones that are the most substantively important link between data and theory. However, don't always take people at face value. They could be trying to do a sales job and selectively reporting their results. Next, choosing your independent variables and control variables you actually want to include in your model. What is your main independent variable? Why is it the most important theoretically? What other important variables might be out there that also could shape your outcome theoretically? And what is also the best link between moving from concept to measure for any of these factors, right? There's a lot of different ways of thinking about absolute value, controlling for the size of the population of a country, or the how developed they are, controlling for outliers. Same kind of factors when dealing with the dependent variable. Now, often people will run hundreds of models and only present a one or two. And as we mentioned in class in the week 7 probability discussion, that just if you run a model 100 times just due to sheer probabilities, you might get 5 out of those 100 models that'll be statistically significant. And so that's why you want to run a bunch of different models. Start with the most standard or influential model, an article that you're really building on. So report your replication of their results, and then compare that to your best model that you think comes closest to estimating the relationship that you see in the world. And then you run a bunch of other supporting models to either incorporate other hypotheses, additional control variables like the positive and negative affect variables in the happiness report that I focused on earlier, as well as methodological concerns. Sometimes there could be different ways of specifying the dependent variable. There isn't enough range, that it doesn't meet the assumptions of ordinary least squares, a bunch of other things that are outside the scope of this class. But the important thing is to think laterally, think frontally about what is the most important to include, what are the threats to inference, do your models end up crossing those 4 causal hurdles, and how can you present your results in a way that highlights the most important aspects of all these hours that you spent to take away the most important elements. Lastly, as I mentioned back in week 6, it's always important to check your sample, the number of observations in your models, the actual data themselves by opening up the spreadsheet and looking at the values, making sure in the descriptive statistics the range is appropriate, the mean, the median are what you think it is. Does it match pre-existing expectations about the larger population that you are theorizing about, that you're trying to connect your sample to the underlying population? Look for potential outliers, as I say, the countries that might have extreme high values of one of your independent variables like GDP, or others like Tajikistan from workshop that could be missing an observation value for one of your variables that could be important to include in your models. Also think about whether your results hold if you had used data from a different point of time. If I used the happiness report in in 2007 or 2008, right after the financial crisis, might the relationship between economic development and happiness be different? Or if you include some countries in your data but not others, are there systematic differences across regions that you might need to think about differences in different regions of the world and how they conceptualize the variables that you're focusing on? So there's a lot of different ways and challenges in thinking about not just the models that you run, but the samples that you're relying on. And then finally, once you have the models that you want to highlight in your paper, or that when you're reading somebody else's paper, you understand that that's just the best approximation that we've come up with, or that the authors of the paper you're reading have come up with, and describe it in a way that allows them to understand what you did, to see how it connects to previous work, and how they might take it forward if they're interested in doing something similar. And then lastly, you want to be able to interpret that, turn it into words, tell the readers what you want them to take away from the table, or when you're reading others' work, you'll often kind of, if you're like me, you might glide across their discussion of their results if you can just look at the results themselves. But I think it's also useful to look at the context and how they might interpret it substantively by plugging in values, like in the Australian happiness example that I mentioned earlier. It's important to understand what they want you to take away from the tables, as well as you. Think about the difference between statistical significance and substantive significance. There could be a coefficient that has a associated p-value that is quite small, but it might be marginal in the larger scheme of things, especially when you compare it against other variables in your model. The book talks about um, standardizing your coefficients in order to be able to compare the substantive size of all the coefficients. Other people will standardize the variable. Most people don't do that in practice. So I think it's important to think about the substantive significance as your variable moves. Let's say GDP moves from 2 standard deviations below the mean to 2 standard deviations above the mean. How large does that affect? How large is that effect on your outcome, happiness in this case? Is it large, or is it just around the margins? Does life expectancy trump that in overall size, or does that also mean less? And you also might want to think about, like, for the life expectancy um, variable in the happiness model, do you want to vary it or plug in values from the very lowest to the very highest, or just take the average values to, let's say, the values of another country that you care about? There's a whole bunch of different ways at trying to just take the statistical significant results and then look at them substantively to tie it back to your research question and your argument, which is why, again, this class is kind of focused on theory motivating all these results, because your statistical program will generate your results, but what you put into the model determines what you're going to get out of it, and you have that substantive knowledge about your specific topic. The program doesn't, and so it's a synthesis of what you know and what has gone before, to be able to allow you to interpret things and to tie it back to your research question and your arguments that you care about. Right, to connect it back to your theory and your hypotheses initially. I'm winding down just to tie it back to those motivating questions. Why do we need to move from bivariate to multivariate regressions? To be able to cross that fourth causal hurdle of making sure there aren't additional other factors that could affect your outcome, are included or controlled for, to isolate that independent effect of your independent variable. How do we do so? We take that similar mathematical approach of y equals alpha plus beta x, and just add in that new z value with that new beta and that updated population coefficient. The way we interpret the betas are slightly different. That you have, if you have multiple independent variables, that coefficient for that one variable is the effect of that one variable holding constant the effect of the other variables in your model. It might seem straightforward, but it's important to understand what it's actually doing and how that ties into everything else being held equal, ceteris paribus assumption that everything that could be theoretically important is included in our model. How we interpret the results are similar to what we did last week with the bivariate models. You look at statistical significance, you look at substantive significance, the sign, size, and significance, right? Is the sign positive or negative? Is it statistically significant? And is that size suggesting that as your independent variable changes, it has a dramatic effect, or just a marginal effect on your dependent variable? So hopefully that provides a bit of context in an explanatory fashion. In workshop this week, we're going to get our hands dirty and trying to actually plug it in and do it ourselves to realize the ways that we can estimate things might be different than others, and how we interpret it and create a table in practice. Here are the important terms for this week: bias, omitted variable bias, perfect multicollinearity, substantive significance, a vector, and then a matrix is just an Excel spreadsheet, right? It's a bunch of different variables and different rows all together. With that, thank you for your time, and I'll see you in workshop.